Now we study static characteristics of SCR. SCR is a silicon controlled rectifier. It is a 4-layer 3-junction PN semiconductor switching device. It has 3 terminal: anode, cathode and gate. It's a PN semiconductor and it is made up of 3 junction J1, J2, J3 with a 3 terminal anode, and this is cathode and this terminal is a gate, and this is a symbolic representation of a SCR. Why it is called as a silicon controlled rectifier is because during its fabrication silicon is used. For that reason we are calling it as a silicon controlled rectifier. So here we are studying the static characteristics of a SCR. Before that we study what happens when we connect a positive terminal to the P layer and negative terminal to the N layer. Suppose if we give a supply, if we provide a supply for the PN semiconductor, that is the P terminal is connected to the positive and the N terminal is connected to the negative, what it says, J1 is in forward bias and J3 is also in forward bias because P is connected to positive and N is connected to negative. Here also N is connected to negative and this P is connected to positive. So we can say this as a junction J1 as well as the junction J3 is a forward bias, but junction J2 is reverse biased. Why it is reverse biased? Because N is connected to P and P is connected to negative. For that reason junction J2 is reverse biased. Now at present this junction as well as this junction is forward biased, J2 is reverse biased, but still a small amount of a leakage current will flow through this SCR, which is very small. Now in order to make it conduct, we need to supply the gate source. So if we apply the gate source, the junction J2 will also get forward biased. Now at this point junction J1, J2, J3, all these 3 junctions are forward biased. Now we study the actual characteristics of SCR. Static anode cathode characteristics of SCR is explained with a circuit. That circuit is over here. This is the circuit. Here this is our SCR, which is whose anode terminal is connected to the supply with the help of a load, and this is our load resistor. Anode terminal is connected to SCR and the negative terminal is connected to the cathode part. This is anode and this is cathode. So the positive terminal of a supply is connected to the anode through load resistor as well as a load, and the negative terminal of the source is connected to the cathode. And here in order to make SCR to on, we need to have a source for a gate also. This is the gate terminal, for which again one more supply ES is providing with the help of a resistor for adjusting the supply to the gate terminal, and one switch is provided over here. So with the help of this circuit we are going to perform 3 modes of operation of SCR. VI characteristics of SCR can be explained in 3 modes of operation. SCR mode of operation, the first one is forward blocking mode, forward conduction mode, and third one is reverse blocking mode. Anode and cathode terminal is connected to the main supply through the load. Gate signal is applied between the gate terminal and the cathode. That is nothing but a explanation of that circuit. First we will see forward blocking mode. Okay, first we see reverse blocking mode. The first mode, reverse blocking mode. As name says the reverse blocking mode, as name says the reverse, so we are supplying the negative terminal to the anode and the positive terminal to the cathode. We are talking about reverse blocking mode. As name says reverse, we are giving a reverse supply for the anode. So anode should be connected to positive, no, but here we are connecting a negative terminal is connected to anode and the positive terminal is connected to the cathode. Then the junction J1 as well as the junction J3 are in reverse biased mode. But junction J2, this one is connected to, N is connected to negative, P is connected to positive, so junction J2 will be forward biased. This is the reverse blocking mode circuit, how it looks. In a reverse blocking mode, in order to perform this operation, negative terminal is connected to anode, but anode is nothing but a positive. But here anode is connected to negative terminal and the cathode is connected to the positive terminal. For that reason, J1 and J3 are in reverse biased, and J2 is in forward biased, keeping gate terminal open, because J2 is also forward biased now. No need of gate pulse. So J1 and J3 are in reverse biased and J2 is in forward biased. When J1 and J3 are in reverse bias, that is a depletion layer is more, depletion layer is not at broken in J1 and J3. J2 is forward biased. A small amount of a leakage current will flow through this SCR, but in reverse direction. That is nothing but a reverse direction, a current is flowing in the SCR. Here we are drawing the graph, this VI characteristics, by taking a voltage across anode on x-axis and the anode current on the y-axis. When it is in reverse bias, a small amount of a current, that is in terms of a milliamps or in terms of a microamps, that is, this is a positive I and this is negative I, a reverse current will flow. So this is the small amount of a current that will flow in SCR in reverse direction. Reverse direction, that is nothing but a minus IA. So this is our reverse leakage current, and the mode of operation is the reverse blocking mode. So if we keep on increasing the voltage that is connected to this SCR, if we keep on increasing the voltage, the reverse current will increase up to one level. After that, it will increase suddenly. So this is nothing but an avalanche breakdown. Sudden increase of current will takes place in SCR. That is nothing but a VBR. If we keep on increasing the voltage in negative direction, whatever the voltage we are giving here is in negative direction because it is reverse bias. If we keep on increasing up at one point, what will happen? A sudden reverse current will increase in the SCR. That is nothing but a avalanche breakdown will occur in the SCR. If we keep on increasing the voltage, means the SCR will damage. So this is reverse blocking mode. It is also called as a off mode of SCR. The another mode of operation is forward blocking mode. In forward blocking mode, as name says, anode is connected to positive terminal. This anode is connected to positive terminal and cathode K is connected to negative terminal. Cathode is represented by a symbol K. Anode is represented by the symbol A. If a anode is connected to positive terminal and a cathode is connected to the negative terminal, that is P is connected to positive and N is connected to negative, means the junction J1 is in forward biased as well as junction J3 is in forward biased because the P terminal is connected to positive, N is connected to negative. Here also the P is connected to positive, N is connected to negative, means the junction J1 as well as the J3 are in forward biased. Only junction J2 is in reverse biased because N is connected to positive and P is connected to negative. For that reason J2 is in reverse biased and J1 and J3 are in forward biased. When a J1 and J3 are in forward biased, J2 is in reverse biased, a small amount of when J1 and J3 are in forward biased and J2 is in reverse biased, a small amount of a leakage current will flow through the SCR, that is represented over here. As this is a forward bias, so the current will increase positively. The small amount of a positive current flow in the SCR. This is that current, that is forward leakage current. Only this much amount of a current will flow in the SCR because the junction J2 is still in reverse biased. Only a small amount of a current will flow through the SCR, that is nothing but a forward leakage current, and the mode of operation is a forward blocking mode. Again this forward blocking mode is a off mode itself. Still SCR is not started to conduct properly. This is forward blocking mode. Next mode of operation is a forward conduction mode. In forward conduction mode, that is a continuation of a forward blocking mode. Here also the same thing, that is see, in forward blocking mode, anode is connected to positive terminal, cathode is connected to the negative terminal. Cathode is connected to a negative terminal, anode is connected to positive terminal. J1 and J3 are in forward biased. A small amount of a leakage current will flow in a SCR, but J2 is in reverse bias. Suppose if we keep on increasing this voltage across this SCR, if we keep on increasing the voltage source across this SCR, at one point the junction J2 will break down and it will start conducting. That is nothing but a forward conduction mode, that is explained over here. If we keep on increasing the voltage VA at one point, that is the forward breakover voltage VBO, at one point the junction J2 will be in forward bias. The junction, as soon as the junction J2 is forward bias, the sudden decrease in voltage will take place and SCR will start conducting. That is nothing but a forward conduction mode. If we keep on increasing the voltage, what happens? At one point, that is a forward breakover voltage, the junction J2 will break down and it will start conducting. So now junction J2 will start conducting. When it starts conducting, that voltage will suddenly reduce to a minimum value and current will start to increase. That is a forward conduction mode. We are applying a positive voltage. For that reason, this is a forward conduction mode. So this is forward conduction mode. Again, here there are two types of currents mentioned over here at N point. So this is our latching current. So this is latching current is the minimum current required to put SCR in on mode. That is in forward conduction mode. And there is one more current that is below point N. So this current is a holding current. The holding current is less than latching current. If the current is decreased below this holding current, SCR will turn off. So this is about forward conduction mode. So three modes of operation. The first one which we explained is a reverse blocking mode. In reverse blocking mode, anode is connected to negative terminal, cathode is connected to positive terminal. That's why junction J1 and J3 are in reverse bias, but J2 is in forward bias. As J2 is in forward bias, a small amount of a leakage current will flow in reverse direction, that is reverse leakage current. Reverse leakage current. If we keep on increasing the reverse voltage, at one point a breakdown will occur, that is a avalanche breakdown, and a sudden rush in current will flow in SCR, that is in reverse direction. If we keep on increasing the voltage, what happens? The SCR will break down, that is reverse blocking mode. Next mode of operation is a forward blocking mode. As name says, forward blocking mode, anode is connected to positive terminal, cathode is connected to a negative terminal. J1 and J3 are in forward bias, but J2 is in reverse bias. Why J2 is reverse bias? Because this N terminal is connected to positive and the P terminal is connected to negative. So for that reason, this junction J2 is in reverse bias. As J1 and J3 are reverse forward bias, the small amount of a current will flow in SCR. That current is over here. That is forward leakage current. Forward leakage current. If we keep on increasing the supply voltage for the SCR, at one point a breakover will occur at junction J2. So here at that point the junction J2 will break and current starts to flow in SCR. So sudden drop in voltage will occur and current will increase. So this is the forward conduction mode. Here there are two main currents, that is at point N and at here. Name it as a M. So this M as well as a N. The point N is nothing but a latching current. This is latching current. Latching current is a minimum current that will flow through SCR to make it in a forward conduction mode. And one more current, that is a holding current. Holding current is a less than latching current. If we reduce the current below this holding current, SCR will turn off. So this is about SCR. Three modes of operation. This same thing. See, one more thing here, whatever the characteristics explained is by making this switch open. We are not closed this switch. Only by increasing voltage or by decreasing the voltage, three modes of operations are explained. Here gate pulse or a gate source is not yet applied. So this is the working circuit which I already explained, and the same graph, but here a gate pulse is considered. This is reverse blocking mode, forward blocking mode and forward conduction mode without applying a gate source or gate pulse. So this is the graph that you have to draw in your exam along with this circuit. You can see here Ig1, Ig2 and Ig3. These are the gate pulses which we applied in the forward conduction mode. See here, in forward conduction mode, the one way of making SCR to conduct is by increasing the voltage. Here, that is when it reaches to VBO, an avalanche breakdown will occur at junction J2 and J1, J2, J3 will start conducting. So it will start conducting. So another way of making SCR to conductor is by applying the gate pulse. If we apply the gate pulse, means it will take a less voltage and it may start conducting at this point. Instead of a VBO, it will start conducting at point V1. So this is the gate current Ig1. And if we increase the gate pulse, so if we increase, that is a more than Ig1, then SCR may start conduct at this point. So the voltage with respect to this one is V2 and the current with respect to this one is Ig2. Here Ig2 is greater than Ig1. If the gate pulse is more, what I am trying to say here is, if a gate current is more, this one, if this gate current is more, immediately the J2 will start conducting, that the current will start to flow in SCR. If more amount of a gate pulse is applied, then SCR will conduct immediately, here only. It will conduct. This is the voltage V1 for Ig1. For example, consider this current as Ig1. Here VBO, where Ig current is 0. because we are not applying any gate pulse, and here is the voltage V1 for a gate pulse Ig1. Similarly, if I apply one more gate pulse means which is smaller than this Ig1, then SCR will conduct at this point, and the voltage with respect to that one is V1, Ig1, V1. So what I am trying to tell here is as gate pulse current increases, the voltage required for the SCR to conduct reduces. That entire thing is explained in this graph. This is the anode voltage, this is anode current. The graph is with respect to anode voltage and anode current. This is a reverse leakage current, this is reverse blocking mode, and the current associated with this one is a reverse leakage current VBR, that is nothing but a reverse breakover voltage. A sudden rush of current will flow in SCR. This is about reverse side. And a forward leakage current, when SCR is in forward mode, forward blocking mode, that is the forward leakage current. A small amount of current will flow. So after that, if we keep on increasing the voltage, at one point a breakdown will occur and J2 will start conduct. So if we keep on increasing the voltage, at one point SCR will suddenly reduce the voltage and it will increase the current. This is without applying the gate pulse. The same thing over here. Without applying the gate pulse, we are starting the SCR, the same thing. If you refer this IG, this is another method of making the SCR into a conduction mode. If we apply the gate pulse Ig1, here VBO is the forward breakover voltage, at current Ig is equals to 0 because we are not applying any current at that point. And if we apply the gate pulse means the SCR may start conducting at this point itself. Instead of taking this much of voltage, it will take this much of voltage to start the SCR. Similarly, if we keep on increasing the gate current means, if I increase the gate current suddenly means the SCR will start at this voltage only. It need not to take this much of voltage to start the SCR. You can see Ig3 is greater than Ig2, Ig2 is greater than Ig1, and Ig1 is greater than Ig, which is Ig is equals to 0. If a more gate pulse is applied, then voltage across the SCR, the voltage which we need to increase across the SCR will be less. If there is no gate pulse, then we can still turn on the SCR by increasing the voltage up to VBO. This is about the forward as well as a forward conduction mode, reverse conduction mode, and forward blocking mode. In exam, you have to draw this one, this circuit as well as this graph. This is only for explanation purpose. Reverse blocking mode, and this is a forward blocking mode, forward conduction mode. So actually you have to draw this one. You can go through this theory. It is clearly mentioned what will happen when we apply the voltage and which junction will be in forward biased. You can see in graph, this is the latching current. Immediately, if a breakover voltage is applied across SCR, the SCR voltage suddenly reduces and it will start conducting. So this current is a latching current and the current below this one is a holding current. So these two are very important. In your power electronics lab, they may ask you in Viva, because in a power electronics lab we need to calculate the latching current, what is the VBO, what is VBR, and what is the gate pulse which is applied to make SCR to conduct. So each and every point they will tell us to calculate. So the latching current After SCR has switched on, there is a minimum current required to sustain conduction even if the gate pulse is removed. This current is called a latching current. Associated with turn on is usually greater than holding current. This SCR you already studied in basic electronics. What happens once a STR starts conducting, even after removing the gate pulse, it will be in a on mode. See, there are different methods of turning on the SCR. One is by increasing the voltage. One is by applying the gate pulse. Suppose if I apply the gate pulse and the SCR is in conduction mode. If I remove that gate pulse means still the SCR will be in on mode itself. That is a specialty of this SCR. Gate pulse is only required to turn on the SCR. If I remove that gate pulse, still the SCR will be in on condition. So this is the current called a latching current. If I this is the minimum current. If I start reducing the current of SCR, so there will be a kit for to conduct this experiment. If I reduce the current across the SCR, that is anode current, if I keep on decreasing the anode current, means at one point, if I reduce below that current means the SCR will be in a on condition even after removing the gate pulse. That is nothing but a latching current. After the SCR has been switched to on state, a certain minimum value of anode current is required to maintain the thyristor in on state. If the anode current is reduced below the critical holding value, the thyristor cannot maintain the current through it and turns off. The latching current and holding current. So this is our latching current. So what it says, the latching current, if I suddenly the current across the SCR starts to increase, that is a property. Suppose a knob will be provided in that kit, and if I reduce the current, so if I keep on reducing this current means at one point, this is a point. If I cross this one, for example, consider this current as a 2 milliamps. If a 2 milliamps means if I reduce the current below this 2 milliamps, still the SCR will be in on condition. That is a latching current. And if I keep on reducing the current at one point, if I reduce the current below that value means SCR will turn off. That is a holding current. The minimum value of a current required to keep the SCR in on state is a holding current, and the latching current is the current that will flow in the anode terminal across the SCR. That is the minimum value of a current that will flow in SCR even after removing the gate pulse. That is a latching current, and holding current is a minimum value of a current which is required to keep the SCR in on state, that is holding current.